What's up, guys? This is Julian with Commercial Refrigeration. We are going to be fixing a micro leak inside of a massive evaporator coil. I found this leak when I did a PM about, I don't remember when, like a week or two ago or something. But my sniffer instantly picked up a scent as soon as I opened the side panel. Took a while. Shout out Rory from Commercial Refrigeration for helping me find the leak, because it took a whole village to find this thing. My supervisor too is here. He's setting up a scissor lift because he has some other stuff he's checking out, but he's getting that stuff set up for me, so all I need to do is bring my equipment in, lift myself up, and make that repair on that leak. There's two ball valves right where the suction and liquid line is, so I'm going to be able to close down the liquid line, and since it's connected, a bunch of EVAPs are connected to one system, it should pump down the coil. So there should be like zero refrigerant or minimal. So I'm gonna, once that pumps down, I'm gonna close off that suction line and get going on repairing the leak. So it's a little tricky one, so you guys are gonna be here for the ride. But as much as it's a little leak, some sounds simple. Solder it up, whatever, braze it up. A lot of equipment's involved, so yeah, come with me for the ride. So I'm moving in. This is what we're working in. Big old walk-in cooler here. Look at the size of these EVAPs right here. Now this one right at the end was the one we're doing our maintenance, and it had to been the last one we're working on. Had to be. You know, long day, long hours, and had to find a leak on a damn EVAP. I got this lift right here to get me up. I get right up in that panel, and I'll show you where it's at once we get up there. But this is what we're working with. I'm going to load up on my equipment and go on from there. This is some of the stuff I'm bringing up. Chances are I didn't bring enough. That's how it usually goes. Yeah, because, you know, sometimes I'd be forgetful and I just be forgetting to load certain stuff up. But we'll see. Maybe I'll get lucky today. It is Monday, but, you know, I do like Mondays. Let's get up there. Alrighty. Hit this extension cord. I have more than enough. It's just making sure it doesn't get all tangled up. There's right here. Just that. There you go. Good there.
Alright, I'm gonna tie this right here. Because everything I have has some length to it. So I'm not really too freaked about anything not having enough room. As long as I have this guy, it should be good. Alright, up we go. And while I go up, gotta make sure my cords are good too. They look pretty solid. What's cool about having the scissor lift is I have a lot of room to play with over here. So what I'm gonna do, I'm gonna move up just a tiny bit. Just make sure I'm not gonna run over my cord. I'm gonna hold that. I'm gonna go a little bit forward. Perfect. That should be more than enough that I need. Alrighty. So now this should be good. If I need to go up a little bit, I'll go up. But as of right now, I'm pretty solid. Get access to this thing right here. This back, don't forget it. Alrighty, look at us go. So let me show you real quick what I'm dealing with here. But it's this pipe right here. Somewhere in the middle there is a leak. I found it with some bubbles. Well, my leak detector kept going off over here, but I could not find it, so I put some bubbles. And it was only until I had my phone pointing down where I actually saw the big bubble on the left side, because it's a little bit of a tight spot right here. But even though we might be blind to the leak, we'll be able to maneuver, you know what I mean, and get that leak patched up. It's a big system, so better to get this thing patched up. Alrighty. Well, one of the first things I'm going to do, get my wireless probe here connected. I'm going to land it right on the suction line. Now I'm doing this just so I could I can make sure that I got as much refrigerant out of the system as possible. So if I remember correctly, this was 448. This part doesn't really matter exact, you know, per se. The my settings and all that, I'm just really looking for pressure. So right now my pressure gauge is zeroed out. I'm good here. So I already took my cap off, so I'm just gonna connect here so I can see what my pressures are, and I'll show you where you could close everything off. So the beauty of these things is, you know, these things got ball valves. You know, these are such big units. They take in like hundreds of pounds of refrigerant, and you know, you can imagine the time it will take to needing to recover everything. So having ball valves right here at the eval just makes repairs of stuff like this very much easier, because not only that, these things take a lot of refrigerant and the time of recovery takes a long time, but the fact is you're gonna have like minimal refrigerant loss during this process. So me being able to cut off the ball valve and watch the pressures drop and cut off the other side, which will be our suction, you know, we're gonna have like minimal refrigerant in here where we're gonna be able to piss it out like just the minimalist amount possible, make our repair, run nitro, vacuum, and we get it done. So let me get over to the first spot, which is our ball valve for that would be important to keep. It's freaking, yeah, that would be very important. So I'm gonna place this in here for now. Basically, we have this big boy right here. So we're just gonna get ourselves a little adjustable wrench, make our movements real quick. Say hi to Mr. Tua. What? I said say hi to Mr. Tua. Alright, bet.
Hey, who's the contactor?
Huh? They're in my van.
Is it unlocked?
Yeah, here. It might have been, but just in case, just take the keys.
I'm gonna go change the contactor, so I'm not turning power off the fan. Because I can go power outside here.
Okay,
so
cool.
If the fan turns off, it's just me.
Yeah, I'm about to close it off, so if it's still running, it's good. I want it to pump down.
Yeah, because the liquid pulls off already.
Yeah.
Just check the suction. Once you get that rolled up,
Close off the suction.
suction.
Yes, sir.
Yeah, but the liquid is closed.
Yes, sir. 100%. Mr. Tua's the man. I just want to let you guys know that. That's our, that's boss man right there. That's El Jefe displaying. That guy's expert technician right there. That man taught me so many great things and made me a better technician. So shout out Tua. Oh my God, but he does keep everybody on their toes and make sure they're doing the best possible job they can. So he was just updating me about the, about him shutting down the unit at the back end. And I'm about to close this off, so he's gonna make sure that my compressor is still running, so this evap is pumping down the refrigerant. So yeah, that's where we're at. So we're gonna get this guy. You know, you can use a smaller adjustable, of course, but my butt did not grab the right one, but this will work fine. You hear it right away. So this is gonna cut off, and we're gonna watch this guy drop here in a second. But look at that, my pressures are dropping. 47, 46.9. We're dropping. So I'm gonna give it about, like 10 minutes, make sure everything's pumped out as much as possible, and then we're gonna make our repair. And I'll get you guys updated here in a bit, okay? All right. So YouTube, one of the things I want to point out, I just closed off the suction, right? Because I got back down to like 36 psi, whatever. But since closing off the suction line, you can see that the remaining refrigerant here is slowly going down. I don't know if you notice that. See 26.5, 25.9, 25.8, 25.7. That leak is drawing out the pressure without me even purging it out. So with that being said, though, this leak needed to get sorted out as soon as possible upon finding it. So just based off me closing both ends of the ball valve here on both the suction and liquid, you can see how detrimental this leak is. So I'm gonna bleed out the rest here. This is mostly vapor, so there's no liquid, none of that. This is minimus releasing of the remaining bit of pressure in the system. Yeah, just letting it bleed. See, it doesn't even want to pick up no more. See, 21, 29, 25. And make this process go a little bit quicker, I will do this. You guys can see what I'm going to be doing here. I'm going to put this right here for now. I'm going to grab myself my core remover. I need to get this guy up in anyways, because I connect my I usually connect my my micron gauge, my vacuum hose on here. I usually take the core out just to give, you know, the best amount of suction possible. So I'm going to take off my gauge for now. Take that off. Put that to the side right here. Get this guy, looks good, and add this guy on here. And I just changed the valves on this guy too, the O-rings, the gaskets and all that. So this guy should be leak free. You know, sometimes you got to change out the components within these core remover tools. But these core removal tools are very cool. I really like using them. So I can close this off, throw in this chingadera right here, and this will remove the core. Now I'm cool with taking off the core for now. And this, and you know, and if you ever have like a leaky core, use a tool like this, and you're able to remove the core, no problem. Put a new one in, and you have like the minimalist like amount of like loss of refrigerant. You know, in today's day and age, refrigerant costs way too much money to be playing around too much. There it is. Here's the core. So we have that out now. So this unit's fully like open now. So when we add in our vacuum line, our gauges again, we could do a more efficient vacuum. We can also connect our like micron gauge, connect just our hoses. You know, if we want to recharge, we could recharge. We could put our gauge probes on here, and I'm gonna show you. I'm gonna put this on the side for now. Safe place. Now if I were going here with my toolbox, let me zero this out once again. Cool. All right, we're gonna add this back on. So I'm gonna put it right at the side piece right here, because this one has a straighter core and this bypasses that ball valve right here. So see if I can do this one-handed. Alright, cool. Now see, already everything comes out pretty easy. If I close it, it's probably gonna be like, yep, pretty low. So we're gonna run this. Should only take like less than a minute, and I'll get back to you guys pretty quick. See right here, we have 0 psi. Hopefully I can get you guys at the correct spot. And I can get my light on here. Spot. I could freaking figure a way how to get this. So darn. There we go. That's a good spot. Good position here. So the main part about brazing and fixing stuff, you know, is the prep work that's involved. So with that being said, a couple methods I'm going to be doing. This is basically ready to go. The first things first, you know, there's going to be a lot of oil on these components. Now, there's different ways you can remove oil. Personally, I like to, you know, you can use simple green, whatever. I like to use like one of this stuff right here. It's might be backwards for you guys, but it's like QD electronic cleaner. So this stuff, you can use these on like circuit boards, you know, electrical safe and all that. This takes down oil very good. So I use this on my tools and all that. Spray some WD-40 after so they're oiled up, remove any rust. But this takes the grime out. So I'm gonna spray this a little bit around it, and then I'm gonna get my wire brush on. See yourself. You know, just getting the methods out here. I'm just gonna do the best I can. It's gonna be a little hard, but best angle as possible. You know, and this stuff, you know, what's great about it is it dries basically kind of on its own. It's almost like rubbing alcohol. So you can see this stuff right here is drying all on its own. So I'm not really worried about wiping it too much, but I'm going to wipe it anyway just to, as a precaution, you know, because you don't want any non-condensables in your system. But this is such a small leak,
it's such a large system that me using something like this shouldn't be a big issue. Typically, I mean, stuff like this should be fine. But once I'm done there, it's like an awkward spot, and it looked like someone tried to repair this at some point before. So I'm just gonna go in here and just brush as best I can, because someone's solder work was done here at some point. I don't know if it's pretty or if they didn't solder good enough. So I'm just gonna get in here and try my best to clean it up. So I'll get back to you guys after a little bit. So I'm just basically gonna hit it up with my wire brush best I can, make sure this entire area is clean, even the front here, because I want to do a whole loop around it. Okay, and honestly, I'll be honest with you guys, this is going to be a very difficult spot to braze, you know, but with my experience, I should be able to get this, leak patched up, you know, because I don't necessarily need the flame on the spot of the leak per se. I just need my flame to reach back there, just so I could, I can get the spot. Then I'll just do some of this, you know, make sure I can get, you know, all this stuff sanded. But I'll get back to you guys when this is all ready and I start my brazing process. Ow, what the sorry, something just happened. That's so weird. Anyways, I got it all cleaned up now, the best of my ability, but you can see where the previous person took a piece of solder to it. Let's see if you can see it from there. Hopefully, yep, you kind of see it. I hope my light's kind of glowing. There it is. So you can see right there how it's like a gabagoo kind of guy. You know, it's super kind of messy. So I don't know who worked on it before. I don't know if it's from my company, different company, handyman. I'm not sure, but I'm not 100% sure where the exact spot of the leak was because it was super dirty. But I'm just gonna go over it with some solder. I'm gonna heat it up, spread whatever is here around. I'm gonna add some. I'm gonna cover this entire side the best of my ability. This is gonna be very difficult just because of the angle, but as long as I'm careful, my experience will guide me. So let's get you guys in position here. I like that a lot better. I think I was at that angle, but I'm very confident about this one. Yeah, there you go. Oh yeah, I feel very good about that one. Like actually, if I grab my mirror, take a good close look. Oh dude. That's actually very good looking. I'm gonna leak check this now, see if I was successful, and if not, you know, take away my refrigeration card. So that looks a lot better. So I'm gonna go through it, see what I can do, see if it's successful, and then I'll get back to you guys. Alright, so we're filling up right now, currently, with our nitro. I'm just gonna hit it up with a little bit of the spray. And we're gonna see if we get any leaks. So really good so far. Pressures are looking good. It's not slowing down. I didn't hear no hissing after I closed it off for a second. So I'm gonna get you guys updated here in a minute once I lather this up pretty good. Okay, it's a little messy, but we'll get it. We'll get it. I just charged the system up with some nitrogen. Put in, I had it set for 150 psi, but this whole evap took my entire tank. So now, I have it filled up to 148 right now. It was at 147 and went up. Alright, so I got the unit pressurized and it held pressure at 148 psi of nitrogen. I held that for about like, I don't know, like 15 minutes. Saw no drop. Checked over my leak. I went through an old video and I was able to pinpoint exactly where it was, and I took a look at that same spot with my bubbles. Got zero reaction. The leak is fully sealed, so I feel very confident that there is zero leaks. The really next real leak test would be me doing a vacuum and let it sit in a vacuum for a little bit. The big problem is I am pretty high up and there's really nowhere for me to leave my vacuum pump besides on these milk crates so I could have it wrapped in. So what I'm gonna do is I'm gonna run it, and it's about my lunchtime, so I made myself a little area for my like little seat spot I can eat my food, and I'm gonna be up here for probably like, I'd say about 10 not 10 minutes, about 30 minutes. So I'm gonna sit back, chill while this unit's going in a vacuum. I mean, I'm hungry, so about to eat. So right now, I have it set up. This is ready to go. Make sure these are tight. And right before, I'm gonna open up my ballast. So this will bypass the oil and just take out the most like non-condensables without wasting much of the oil. So I'm gonna turn it on, open this guy up, let it do its thing. So now I can feel it right here. A lot of yeah, you can see it right there. See? So I'm gonna let this run. See, I'm already getting some readings. So I'm gonna leave the ballast open until I reach maybe like somewhere under 10,000 microns, probably like, or 1,000 microns. So once I hit about under 1,000 microns, I'm going to close the ballast and let it do its thing. Let it reach down to 500 microns and see if it holds, you know. So the biggest thing is you can nitrogen test, you know, and it should be good for the most part if it doesn't leak out. But another good test is you vacuum it and let it sit for a bit, because you're really pulling in you know, you're taking out all the oxygen, all the non-condensables, moisture out of the system. Some little thing could plug up a potential micro leak. So when you're using your vacuum pump and you're pulling out all the non-condensables, you're really kind of clearing out the system. And if you let it sit without vacuuming and you keep an eye on your microns, it shouldn't move if there's no leak. If it leaks and there's like a drop in or a rise in pressure, I'd say, then there's obviously going to be a really small leak somewhere. But I'm going to keep an eye on it. So far, I mean, good sign is dropping microns pretty fast. Usually when there's a big leak, it does not drop this fast. So I'm gonna start another video in a little second once this is done, but as of right now, vacuum's rolling, microns going. I'm at 1800, so I'm at that point where I'm about to close up my ballast. But I'll see you guys here in a little bit once I'm all done, and I'm gonna open up my ball valve. So see you guys in a bit. Alright, show you guys. I have it closed right now. It's stuck at 470 microns. Alright guys, let me update you real quick. We're at 470 microns. All right, so it's stuck at 470 microns. We're looking great. So did its job.
What? Damn. Alright, open the ball valves and turn it on. Look at that. Alrighty, we're running fully now. I got both ball valves open.
All right, so I'm in my van now, packed up all my equipment. Like first 2 minutes of it being on, there was already a 10-degree temperature difference going into the coil and coming out. There's 3 other evaporator fans in there that is removing heat constantly in there. That box could run with just 3, probably even 2 evap fans running. So even if one evap goes down, it's not gonna be bad for the box itself. It's gonna keep everything under 40 degrees. But nonetheless, we want all units to be working properly. It's just gonna keep from the other units having to work as hard. So the box temperature is at 39 degrees, dropping. It's doing its thing. Honestly, the patchwork was successful. Yeah, honestly, I hope some people can learn a thing or two. And you know, some of this stuff's not necessarily easy. Sometimes you get a little bit uncomfortable, but hey, we get paid to be uncomfortable sometimes. So other than that, I'm all good. Julian from Sacramento Refrigeration here. Hope to see you guys soon.